question there was talking about, we had a function f of x is equal to 2 sine pi over 2x plus 1. And we were supposed to, a part says, show that the derivative equals pi cosine pi by 2x. So that's what we're asked to try and find out. So in order to do that, well, let's take our scenario here, and we're going to go f prime x. I have 2, derivative of sine is cosine pi by 2x. Chain rule says the derivative of the inside function is pi by 2 plus a 0. Well, that cancels with this, and I'm left with pi cosine pi by 2x. Alright, and now let's just see a graph of this, what's going on here. So here is our function, here is our original function. The next thing we're told is that the tangent line, so here's our derivative. So now b part says we're told y equals k minus pi x, and we are asked to find where does the tangent, this is the tangent, where does the tangent meet the function f of x? So what's the x value equals what? Well, here's my derivative. The derivative and the tangent line are related. The derivative is the slope of the tangent. Well, here's the equation of the tangent, and then we know that this right here is the slope of the tangent. And so that tangent, this tangent, slope, this is also slope. So if we set them equal to each other, we can find our x value. So if I say pi cosine of pi over 2x is equal to minus pi, be careful, it's minus pi is my slope right there. I divide everything by pi, both sides, and I get cosine pi by 2x equals -1. Now, if you look at the equation had told us that 0 is less than or equal to x, less than or equal to 5. So that's our interval for x. My angle, though, is pi by 2x. So I'm going to take this interval and multiply it by pi over 2. 0 times pi over 2 is 0. And this is 5 pi over 2. So I have to go around a couple times this circle. So here's my angle. I'm going to think about cosine. Here's my unit circle. Cosine is my x coordinate. Here is +1. Here is -1. So I have to go around to pi. And then I got to go around to 3 pi. Well, that's 3 pi is more than this. So pi is my only answer. Divided now by pi over, well, I'm going to multiply actually by 2 times pi. Multiplied by 2 times pi. And x equals 2. This is where the tangent meets f of x. So if I look at the graph, here is this. It's saying the tangent, there's going to be at 2 meets the curve. Here's got to be the tangent line, something like that. Now, the next part of the question is saying, well, if this is the tangent, up here there's going to be a y-intercept. It's got to intersect, we've got to find the value of k. So, now I know this is x. If I go and find my y value in my function, I can plug y in and x, and I can find k. So let us find k. We are first going to go f at 2 into the original function up here. So it's 2 sine pi over 2 times 2 plus 1 which is 2 the sine of pi plus 1. The sine of pi, well, if the y value is 0 plus 1, so I get 1. So the coordinate is 2, 1. And again, if I look at my graph, that is 1. That is a good check there. Alright, so moving along then. Now, this point on the curve is also on the tangent line. If I plug it in, I get 1 is equal to k minus pi times 2. So 1 equals k minus 2 pi. Add this over, and so k will be 1 plus 2 pi. That's the k value. Okay. And finally, the very last part of the question says to solve the equation that says f of x equals 2 over this interval. Well, you have your calculator, right? And so what I'm going to do, I'm going to take my equation here, and it's saying equal to 2. I'm going to find, I have to find this point, and that point. Well, I can do it analytically, or I can do it algebraically. So if I use my y equal to 2 here, I put that equation on there, and if I come along and select them both, I can find the intersection. And if I look at it, I should have it down here. I get x is 0.3332, 1.6672, and 4.334. And those right there are going to be your answers to the last part. Just the x values are what you need. And that will solve this. There are 3 answers. Get them from your graph.